That's the first part there. We've got our strike, okay? Right, the bearing of a level line. So if we were to draw the elevation of the line there from, we'll call it say E to P. If we were to draw that elevation up here, there would be a horizontal line or line parallel with the horizontal plane, because E and P are both the same height, 45. Now the dip then, right? The dip is the second part. So we've got the strike, now we're going for the dip. Now the dip is the angle that this stratum here, EDF, or in other words the plane. So we're looking for the angle that the plane containing the three of them points makes with the horizontal, or makes with the ground. The way to get an edge view, because that's what we have to do, of any plane, is to look along a line on that plane that's true length. We know EP is the true length here, so we're going to project along that line. Okay? So I'm going to put, I'll use my darker pencil so that you can see it. I won't, I don't know where it is. Right, so project along there, project along there, and project along there. Right, now I'll have to bring F up a bit farther, I'd imagine. Now, your new XY line then has to be, of course, what to the strike? Perpendicular, good. Right, so, and I'll keep it nice and close to that. Right, so this is our. Now, all you're doing here is an auxiliary view, like you do in the orthographic, the ordinary level orthographic question when you're getting the true shape of the surface. Except this time we're not projecting off the surface, we're projecting along a line. Now, here's what came up there a minute ago with the ordinary level question, the location of these points, right? I know D is 35, so I can mark up 35 for D. E is 45, I can mark up 45, and F is 60, I can mark up 60. Now what you could do is, if you put D on this line, that then means that the XY line is actually 35 up. So for E that's 45, you'd only come up 10 mil, and from F you come up, but I prefer to keep it as the full length. So in other words, F is 60 mil up, so you mark up 60 mil here, that's F. Now I always get the bottom one then, which would be D here, that's 35. You can join them, right? And of course then that should be 45 there, and it is. So I'll mark them 3 points there now, right? This is D, this here is E, and this one here is F. And that is an edge view of our stratum of ore. Okay? So I'm going to put it in green because basically, right, this is in green here, so that's the edge view of that. Now the dip is the angle that this stratum makes with the horizontal. So you could project them lines down until they meet like this. Right? That's the angle there. But what we do, as we said already, is we bring our XY up to it. Right? Right? Because that is the horizontal there, that's your ground. So then what we do is we'll just mark. Right, so this is that little angle in there, that's our dip. So that's the strike done, the bearing of a true length line. Now remember that for the next one, because you'll be doing the next one yourselves, right? You get the middle of the 3 heights, the side opposite you divide it up into 5 meter intervals, and then like look, if you wanted you can mark, okay, that'd be 40, 45, 50, 55, 60. So that point is 55 up, that point is 50, that one is 45, that's 40, and we know D is 35. Right? Now, the next part of the question then. A skew borehole at D is drilled in a northerly direction in plan. Now where is the plan? Here. So if it's drilled in a northerly direction, it's drilled straight up. Now unfortunately, because of the way coincidentally I brought up the line to divide it up there, this line is going to be more or less on that one. Right? We're bringing a line up there from D, right, in a northerly direction. Now I don't know how long it is yet, right? But if you read the question, it has an actual inclination of 45 degrees to the horizontal plane. It reveals the bottom surface of the stratum at a distance of 20 meters from D. Determine the thickness of the stratum. So the thickness of the stratum, like in the last one we were told it was 10. So we came to this part of it. we project it off perpendicular, we marked it 10 below, right? In this one we're told that a skew borehole, right, which is a hole that's drilled but it's not drilled vertically. Because what would a hole that's drilled vertically in plan appear as? A point, right, because you just see the top of it drilled down. Because it's a skew borehole, it's drilled down at an angle. Now we're told that the angle of that line is 45 degrees to the horizontal, or to the horizontal plane. Now, to get the actual angle of any line, right, and you're going to meet this a lot in C3, to get any line given its true angle, you project off of it perpendicular, right? So, because it's drilled northerly, I know that's a vertical line, so to project off it perpendicular, I'll be coming out horizontal, okay? I'm going to pick a point here, D. I'll do my new XY line first. Right? Now, how high is D up, do we know? D is on the 35 contour, so I'm going to measure up 35 there. Right, now we're nearly crossing into the other drawing, that's alright. So that's where D is at the moment. Now, what angle were we told that actually makes with the horizontal? 45, right? So, basically, if you were to come down from D, right? If I was to come down there from D at 45 degrees, right? So this is 45 degrees in here, there, right? That's the angle that D makes. Now, we're told then that the bottom surface of the stratum of ore is how far from D in the question? 20 meters. Now, if it's 20 meters, what will it be on this sheet? 20 millimeters because of the scale. So what I do is I come 20 down from D and I mark a point here. Now this is actually that's our important point here, right? Can't call it P because we've already called it P. So call it point G, right? Now, point G, if we read the question again, right? Skew borehole is drilled at D in an northerly direction. So I drew it straight up there, right? Because I knew it was drilled in a northerly direction. It has an actual inclination of 45 degrees to the horizontal plane. So if you have a line and you project off it perpendicular, you'll get that line's inclination to the horizontal plane, taking its heights, right? We knew the height of D was up 40, or 35 I should say, because it's on the 35 contour line. Then we knew that the angle that that line makes with the horizontal, or with the ground, or with the horizontal plane is 45. So I made this angle here 45 degrees. Okay? And then we knew that it was 20 mil below. So the bottom surface of the stratum is a distance of 20 mil from D. Now, what I want to do is I need to get G back here, and then I need to get G back up here. Okay? So, firstly, you project G back till it hits the line coming up from D. And that gives us our skew borehole there. And that's point G. Now, to get G over here, in this view, with all of these points, D, E, F, right, and P, we projected along the strike. So now that we've located G here in this view, we're going to project G at the same angle, okay? So you line your strike up like this. And we project D up. Now, I know G is on the bottom of the stratum of ore, right? And the last part of the question is determine the thickness of the stratum, right? So I know somewhere along that line up here lies G. And when I have that, I have the thickness of the stratum. But how do I get what height G is up? No, it's not where it hits the line. Remember, this is an elevation now, and this view here was an elevation. D is up 35 here, and D was up 35 here. So what will I do with the height of G here? It's going to be the same. So I get the height of G on my compass here, right? Or the point that's 20 mil below D, and I mark it up here. That there is point G. Now if G is on the bottom of the stratum of ore, what can I draw through G here? Parallel line, exactly. Parallel to the top of the surface of the top surface of the stratum of ore. There, yeah, from X, Y. Because like D, we came up 35 there for D, because that's its true height. Then we come up from X and Y for G here, and we mark that height there. Okay. Now, have I determined the thickness of the stratum? Have I indicated it? So look, all I'm going to do is just, and again, this has to be a perpendicular line, right? Right? Just going to write thickness here. Now it doesn't say indicate in meters. If it did, you'd measure it, right? And it's 19 millimeters, so the thickness of it would actually be 19 meters, right? But it doesn't say indicate in millimeters, it just says determine. That's the thickness there then, from that point to that point.